understand as well what your tracks are doing. If you've got one power feed that's feeding a motor, for example, that's going to take a lot more current through that trace than one that's just signalling something as an input. Yeah? So you would make that track thicker, and if it was particularly large, then you would want to understand the maximum current that's going to go through there, and you would use a PCB calculator like Saturn PCB calculator, it's a free download, where you can put in the width of your track, the height of your track, and it will tell you the maximum current that it can pass through safely. Yeah? So you've got to understand that. Another area that you need to consider are differential traces, how far or how close they need to be together for differential signaling. RF traces, there may be impedance control. For example, if you're feeding an antenna and you need to have a 50 ohm input impedance to that antenna, then your trace needs to be a 50 ohm impedance control trace. And you would express that to the fabrication plant, and you would tell them this track needs to be 50 ohms, and they will adjust the width of your track in relation to the ground plane and the side ground to make sure it's 50 ohms for you. Okay? So there's a couple of exceptions that you might end up with. So we've exported this, we've got our thing here, we've got our size in there, we've set 5 boards we're looking for. The board's like a single piece, which means that they'll come as 5 individual boards in a pack. They won't be as a panel, they will break it for us. We want 1 ounce copper on the top, which is the standard. You can choose the colour of your solder mask, colour of your silk screen, entirely up to you. Here we go with minimum trace and width spacing. Now, as you can see, their default is at 1010, which is mil. You see that mil there? M-I-L. That is not millimetres. That is thousandths of an inch, which is why I say PCBs tend to be in imperial, whereas schematics tend to be in metric. I don't know why, it is how it is. So what they're saying here is we really want you to be giving us 10 thou by 10 thou. So minimum width of your track should be 10 thou, and then the spacing between the individual tracks should be 10 thou. If I was to say, well, actually, I've got 5.5, my cost here is $28.99 at the moment, very reasonable. If I select 5.5, suddenly, oh, it hasn't made any difference, which is quite nice. Let's try actually a bit here. There we go. If I go 3.3, then my cost will turn up, because the manufacturing process is more involved. Okay? So 1010 is a good starting place. Minimum drill hole, so you should understand if you put any holes or veers in your board, then what's the minimum that you're going to have? Because again, if you want a 0.12 mil, the chances are this is not going to happen. It's quite good one. This isn't PCB Way, by the way. This is a PCB Basic. Yeah. The veers that you've chosen, all this kind of stuff, surface finish. Whether you want a lead-free finish or a gold, immersion gold finish, etc. Again, all this stuff is going to change the cost of your board. So if I want gold, I've doubled the price. If I go for a lead-free, I get a much cheaper option. Your impedance control, as I've just explained, if you want that, it's going to put your price up. So you go through all of these, hopefully you can leave them all as basic. Without changing the defaults to keep your cost as small as possible. When you've done all that, what you can do is upload your Java file. Yeah? So we can take our PCB design file. Okay, so upload that file, and now it's going to do a check on the file, yeah. And so it's going to have a check that all the files that it needs are there, and it's going to give you an analysis of what your board looks like. To give you a yeah, that's roughly okay.
That's the final sanity check, isn't it? So all the little boxes that you've ticked and all the rest of it and stuff. If you can see that picture at the end of it, put that in your report to show you evidence that you are ready to manufacture.
Exactly that, yeah. And then, and when you're happy with that, if you then take a picture of this, if you want to manufacture your board, obviously you can, you have to pay money, and then a couple of weeks later, your board will appear, you can throw the components on and test out your design. But I think for the report requirements, just to dump that page.
Just a dump of that page with the printed circuit board on it to show that you've been through that process.
Along with your bill of material and potentially your schematics in the appendix of your report.
Yeah, the bill of materials is just, if you look on the web page, there's it's only a spreadsheet with 2 columns in it, but it's got, you know, resistor, part of a purchase of 1,000 or whatever it is, you know. So you have to do it real world stuff, because you're not going to find anyone that's going to sell you one 1K resistor, are you? It's just not going to happen.
It's going to cost a lot. But ideally, you want to make that bill of material so that you were going to give it to someone in the office and they would be able to order your parts, which means that you'll need a quantity, a description, a supplier, whether it's a Farnell, a Mauser, or an RS, or whatever, and the price and the minimum order quantity. That's really important because that brings it home as to whether you think, oh, that's perfect and it's really cheap because it's 0.001p, but you find out you have to buy 500,000 of them to get that price. And that's how electronics work, especially with resistors.
Just like the grocers, isn't it? When you go and buy oranges or grapes or anything like that, it's unusual to buy one, so you have to buy a whole load, and the more you buy, the cheaper you get them. But then you might not want all the oranges because they might go rotten before you eat them. So
if you can imagine, these are big machines. They're not going to want to put individual resistors in there. They put reels, normally reels of resistors, which have got 5,000, 10,000 on a roll, and then your chips. If you've got an IC, a 555, it will come in a tube, and the tube would have, say, 30, and then put that in the machine, and the machine would take the one off the end. I mean, that's how they work. So, yeah. Okay, so that's your PCB, that's your design. I think that's covered.
I think we're done. Yeah.
All good.